Today, my talk, it's kind of, in a way, maybe some people will be thinking that I am judging. So, but in knowledge, we don't judge each other. We always look to our drawbacks. We always look to our weaknesses. So before I am going into details, I would like to share with you that personally I came from a very kind of poor background in physics. I got my FSc from my hometown, Matta, then BSc from Janzib College, Swat, and MSc from Peshawar University, and MPhil from Solid State Center. So it's a kind of home to me. Coming back to Punjab University, it's going back to home. So I'm always proud to be here for any activity. And after that, then I went to Qayyazam University. I spent 1 year in my Ph.D. and from there, then I went to USA, got my Ph.D. from there. My work experience is basically in different places like Peshawar University, Islamia College Peshawar, Hazara University, University of Malakand, Louisiana State University, University of Idaho, USA. And I had also experience of working at University of Technology, UTM, Malaysia. So talking about these things, when I'm talking, the main thing for me is the basic education, the basic understanding. If we don't understand things, then, like producing results will be meaningless. So before going into details, I would like to share with you a questionnaire, and I would love you people to fill it out. Okay, this talk is more a kind of, I want to keep it more interactive. If you want to, like put some input, you people can stop me. Or if you people don't understand anything, you people can stop me. So I want to keep it interactive because this time is very difficult for a lecture. Before coming here, I had a discussion with some persons, and I told him that for me, physics can work only and only from 8 to 10. Maybe somewhat you can, like try from 10 to 12 or 1, but after that, it's almost impossible. Did you get my point? Yeah, देखिए कि फिजिक्स का लेक्चर दोपहर के खाने के बाद समझ आता है या नहीं आता है? नहीं आता है ना? मैं वही कह रहा हूं कि the best time is from 8 to 10, and then from 10 to 12 it might be okay. And that's why what happened when I came and I started my journey, I started from curriculum development. Then along with the curriculum development, it was like Azara University, so I also basically changed the whole scenario, and I said that the MPhil PhD people should be more responsible than anybody else. So if the classes starts 8 o'clock, MPhil PhD should start 8 o'clock. Their classes should be more serious, और उनका जो है उन पर ज्यादा सख्ती हो गई, और सख्ती का फिर ultimately what happened when we produced some very good physicists. So anyway, where is the problem? Coming to the topic, the first thing is, I gave you people 3 questions. Before going into further details, I'm sure that everybody is thinking that he or she has given the right answer. And everybody is thinking that why he gave us such simple questions, right? Questions are very simple. Like we have, like starting from a question that the potential energy of a particle of mass m placed on a table of height h. Here is a mass m placed here and the height of the table is h. I'm sure that everybody writes mgh, right? Right or wrong? What is potential energy? Is it a scalar quantity or a vector quantity? For sure, it is a. What if I have said that the bottle, it was placed on the ground? So for sure, everybody would have said that this is zero, right? But the question is this, that my results or anybody else's results, we compare things. And when we calculate potential energy at all levels, the equation comes out now. The first thing is, when we talk about any particle, is it a bound particle or not bound particle? Right? Bound or not bound? Bound. So whenever we talk about the energy of a particle, if you remember, like for electron in FSC and BSC, our total energy was minus k squared. Something like this. I was also thinking that why we have the negative sign? Why we have the negative sign? Why the things are coming out like this? What is the logic? What is the reason? कभी मुझे इसका आंसर नहीं मिला. Because the problem with our physics in Pakistan is this, that the first thing we go for is our metric, and after metric then we go for FSC, and the books are focused on memorization. The books are focused on memorization. So हम रट्टा लगाते हैं. That's all what we do. Is it the purpose of physics? Maybe not. Physics, basically what physics does, it basically develops your problem solving skills, your critical thinking, your analytical skills. Your analytical skills. Now when I say that the bottle is here, तो रट्टे वाली बात MGH, right? Because we memorize this way. We memorize this way. That we always compare the potential energy with the surface of the earth. We never look to the potential energy. That is the potential energy, right? मेरे ख्याल में कोई आप लोग कुछ लोग ये एक जवान जो है थोड़ा सा कंफ्यूज मुझे लग रहा है. समझ आ रही है मेरी बात? कौन सा आसान है? MGH आसान है या ये आसान है? MGH बहुत आसान है. Because we think that way. We think that way. हमारे beliefs बन गए हैं कि wherever there is a potential energy, we will be just going and we will be picking the things and we will. And this problem is not only coming from the textbooks here, but this problem is also in the textbook which are like from abroad, like Holiday, Resnick and other textbooks which we teach in introductory level. Then in the later classes, अगर आप लोगों को याद हो हमने ये चीज किए हुआ है, we have done it and we have derived it. We do it again and again. Do people remember the escape velocity? Yes or no? So where the escape velocity is coming from? Because you are taking the potential energy of the particle and you are taking the kinetic energy of the particle. You are adding both of them and then you say that the minimum escape velocity is this thing. Right? Is it right or wrong? ऐसा ही है. Because when we talk about the potential energy, whenever we talk about the potential energy, the first thing comes up that we are bound. We are bound. We are in a bound system. We are in a potential well. We are in a potential well. ये नहीं है कि सिर्फ इलेक्ट्रॉन इज अ पोटेंशियल वेल. हम तो उसका सोचते हैं लेकिन अपना नहीं सोचते. We are also in a potential, but our potential well is gravitational potential well. And the understanding of this thing is very important. If you don't understand this, naturally अगर आपको basics इन चीजों का अंदाजा नहीं हो तो फिर आगे जाना हमारे लिए comparatively. Now coming to another point. कोई क्वेश्चन या है इसके बारे में? अब भी अगर किसी को क्लियर नहीं हो कि पोटेंशियल एनर्जी क्या होगी, अब तो क्लियर है ना? क्लियर है या नहीं क्लियर? जमीन के सरफेस पर पोटेंशियल एनर्जी. ओके, लेट मी टेल यू वन थिंग मोर. मेरे ख्याल में इधर ये चीज आवाज बहुत. Remember that potential energy is a scalar quantity. Potential energy is a scalar quantity. Once you define your reference, then you can do it. Once you define your reference, let's suppose I say that my potential energy at the surface of Earth is 0. Then I will say that this is mgh. But before saying that this is mgh, is it right? I have not. Because then it gives me the difference in potential energy. mgh is not your potential energy. mgh is not your absolute potential energy, but this gives you the difference in potential energy. But the first thing you have to do is to define your reference pair. Whenever you solve a problem, once I define that the surface, I can say that this is 0. I don't say that that is 0. I'm right. This is on me to choose any point that suits to me or my problem. बात समझ गए? नहीं समझे? नहीं समझे? भी नहीं समझे? mgh, I say that this potential energy is 0 because I assume that the potential energy of this surface is 0. Another person says that I assume this is mgh as considered Earth, the surface of Earth, as 0 potential energy. So from one point to another point, जिस तरह हमने mgh पढ़ा है, that is basically not the absolute potential energy, but that is the difference in potential energy. Now a person says that the potential energy of this bottle here is 0. Is the person wrong or right? Yeah, this height is h. But the person says that the potential energy of this bottle is 0. The person is right. Because the person considers that this is my reference point. But the other person who is solving the same problem, he says no, this reference point makes problems for me problem difficult. So I want to consider the surface of earth as a reference point. Now that person is also right. Now we need answer which is acceptable to both. We need answer which is acceptable to both. About this answer. Whatever they do, they don't have any choice. They don't have any choice because this gives me the absolute potential energy of the bottle. It gives me the absolute potential energy of the bottle. So I'm not taking any reference in this case. The reference is the center of the earth. The center of the. So from there I go anywhere and I can pick the things. And this is more realistic because it also tells me the other point which is more important. That the particle is in a potential. The body is in a potential well. The body is in a potential gravitational potential well. Now coming to the other point. अब तो मेरे ख्याल में क्लियर हो गया या नहीं अभी भी कोई मसला है. Now coming to the next point, मेरे ख्याल में आखिर में मुझे अंदाजा है आप लोगों के questions भी होंगे और फिर comments भी होंगे. We will come to that point and now the second point, I'm coming to the first question. Diffraction of light. Diffraction of. Diffraction happens when the light is comparable to, when the wavelength is comparable to the slit size. सबने यही लिखा होगा. Approximately equal to ऐसा लिखा है ना. अच्छा बाय द वे किसी ने किताब में इसको पढ़ा? हाँ यस किसने पढ़ा है? अच्छा वो क्या कहते हैं किताब क्या कहते हैं कंपेरेबल टू here go. Now the problem here is this that मतलब ये है कि this is the base of optics. Optics starts from here and if our this belief is wrong, so what will happen to our other beliefs in optics? मेरी बात समझ आ रही है या नहीं आ रही है? What will happen to our other beliefs? Naturally the other beliefs जो है वो तो इससे भी उनका बुरा हाल होगा, right? So the question is this, that how many of you have gone through the textbook of Holiday Resnick? Did anybody read this topic in Holiday Resnick? Yes or no? Yes कि बात देखिए कि the person who has read it, देखिए yes, don't talk about notes, don't talk about ilmi guide, tell me about the textbook Holiday Resnick जो है क्रेन है या वॉकर है या whatever या any other good textbook other than Indians और पाकिस्तानी. ये बेसिकली मसाइल का जोड़ यही है. Everybody is looking for something जो है उसको बस मुंह में उसको चबाने की भी जरूरत नहीं हो. वो किसी ने पढ़ा है नहीं पढ़ा है. Now again, now we can say that there is a problem. There is a problem. If we have not read something, we memorize something from our notes and the notes were wrong, फिर क्या होगा? हमारे beliefs बन जाते हैं. हमारे beliefs बन जाते हैं. Our those wrong beliefs, what happened? You know this point why I want to discuss it. I had very hard time in teaching quantum mechanics to my MPhil class because I'm teaching a book of Kohan Tanduji. And it is a philosophical book, and the book starts from double slit experiment. The book starts from double slit experiment. Now, if a person doesn't know about single slit diffraction, and the person doesn't know about double slit interference and diffraction phenomena, can I teach quantum mechanics to them? Because this is the base. The person has to start from here. The person has to start from here. तो कभी कभी मैं जब एमफिल या पीएचडी को पढ़ाता हूं तो ज्यादा टाइम मेरा पहले चैप्टर पर लगता है. And many of them they don't agree with me initially, because जिस तरह MGH वाली कहानी है, we have the same sort of beliefs that the wavelength should be comparable to slit size. But technically this is not right. Technically this is not right when we say that this is approximately, because when we say comparably, it comes to our mind that this is approximately. This is right. So what happens if you go to the diffraction pattern? This is the diffraction pattern of a single slit. This is the diffraction pattern of a single slit. Now, if you see this pattern, if you change its size, the sharpness of the pattern will change. The sharpness of the pattern will change. And this is our first minima. Okay. Again, when you go there, many people they confuses this with the, the other experiment we had, like in solid state physics. This is a single slit diffraction phenomena, and the single slit diffraction phenomena, this is for first minima. The equation is like this. The equation is like this. Now what happens to the pattern? This pattern will change when you change the wavelength of a light, or you change the slit size. The slit, the pattern will be very sharp when the slit size is 10 times larger than the wavelength. बात समझ आई है या नहीं आई? मैंने ये कहा है कि the pattern will be sharp when the wavelength is 10 times, मतलब ये है कि slit size is 10 times of the wavelength. 10 times of the wavelength. मैंने ये नहीं कहा कि उसके बाद डिफ्रैक्शन नहीं होगी. उसके बाद डिफ्रैक्शन होगी या नहीं होगी? If we increase the slit size, yes, the diffraction will happen. Now, where this misconception came in our mind from this approximately, कोई बता सकते हैं कि where this concept came? कि जो हम सोचते हैं ना कि the slit size must be comparable, or the slit size must be approximately equal to the wavelength. ये कहां से ये मसला आ गया है? कोई बता सकता है? नहीं बता सकता है. Maybe not. अच्छा, what happens to this equation? You know, like your lambda by A, if they are comparable, then what will happen? This will be equal to 1. Sine inverse 1 is equal to 90 degree. Did you people get my point or not? So you change with the changing of this thing will change. This first minima. And the first minima, if you compare the slit size and the wavelength, when both of these are equal, then this thing will reach to where? It will occur at 90 degree. It will occur at 90 degree. What happens? ये जो आपके पास if the light is coming through here, और आप इसको मतलब ये है कि what happens if you squeeze the light? The dispersion will increase. The dispersion will increase. And when both equal, so the dispersion, it goes up to 90 degrees. With 90 degree, what happens? Because the light everywhere will be the same. ऐसा होगा या नहीं होगा? मेरे ख्याल में लगता मुझे ये है कि इस चीज को आप लोग समझ नहीं रहे. बात समझ आ रही है मेरी? हाँ, आ रही है ना? कि देखिए ये स्लिट साइज मैं चेंज कर रहा हूं. So with the changing slit size, this thing is shifting. At 10th we had a very sharp, but when I squeezing the light, uncertainty principle है, uncertainty. आपने इसको position को confine कर दिया, momentum will be uncertain. So with that what happens? It goes on and on and on and on. When both are equal, then in that case we say that this thing happens at 90 degree. It means that everywhere the light is the same. Two slits. We have 3 slits. We have 4 slits. Because if you remember that in interference, we say that it's like this. ऐसा होता है ना? Every band has the same intensity. Every band has the same intensity. The size of each band is the same. ऐसा होता है या नहीं होता है? ऐसा होता है ना? What about the diffraction? Intensity is not the same. You see that the intensity is decaying. The intensity is decaying. The size is changed here. It is huge. वो जो दरमियान वाला spot होता है, when you go away, it becomes smaller and smaller and smaller. So now I'm coming to the point that this idea that for interference you need diffraction, and that diffraction be such that gives you the same pattern. That gives you the same. वो जो बैंड्स होती है ना, ब्राइट एंड डार्क, हम इंटरफियरेंस में कहते हैं कि वो एक जैसे होते हैं ना, वो तो तभी होगी कि जब हमारे पास लाइट फॉलिंग एवरीवेयर इज द सेम. लाइट फॉलिंग एवरीवेयर इज, दैट्स ओनली पॉसिबल जब the slit size equation says that lambda is approximately or equivalent to A. Other than that, what happens? No. There will be interference superimposed by diffraction. दोनों phenomena will occur. मतलब ये है कि in the whole process. So anyway, I just wanted to share with you like something about this. कुछ चीजें if something is not clear, very basic thing is not clear to us, start something difficult based on those things. तो वही it reminds me when I was in USA, started Kohan Tanuji book, started everything from here. And my background was just like you people. अब आप एज्यूम करें कि आपको चैप्टर दिया जाता है, यू कम विद दिस टुमारो, and your beliefs is this, that the slit size must be comparable to a wavelength. So can we do it? Maybe not. So I was lost. I don't know how did I pass the course. I pass it with B grade. But anyway, this is what happened with me, and I understood those problems. Because going from this background to USA and taking courses over there, it was very difficult for me, and I'm sure this is the same for everybody. And this is something we need to address. ये हमारी responsibility है, हम सब faculty members की responsibility. We coming from a poor background, but we don't want our generation, next generation to be like us. We want them to be very strong. Wherever they go, they are more effective. They can add to the knowledge. ऐसा ना हो कि वो पुराने में लगे हो, पिछली चीजों को सीख रहे हो. Now the last question I have asked, मुझे पता है कि everybody knows that they have done it right, and basically the book says that that is right, right? The wave function of a plane wave. So the wave function of a plane wave जो है उसमें अगर आप लोग देखें तो मेरे ख्याल में everybody is happy that I have written psi is equal to AE is it a wave function for a plane wave, right? It is a wave function for a pre-particle, right? सही है या सही नहीं? सही है, नहीं सही है, सही है या सही नहीं है? मैं बहरहाल it was written, I am sure that majority of the people say that this is, अगर सही नहीं है, why this is not right? We had a discussion before this, we had a long discussion on this topic. डॉक्टर साहब के साथ थोड़ा सा हमने डिस्कस किया this thing. देखिए, we are talking about probability density. But when we talk about probability density, we need to understand probability. What is the maximum probability of any event? 1. If the probability is 1, then thinking about this, अगर मैं इसकी probability, so what will be I am getting for this probability from minus infinity to plus infinity? Look, you people said that this is the wave function for a free particle. This is the wave function for a free particle. This is a wave function for a free particle, and majority of the books, even the foreign books, most of them, when they talk about the wave function, they say that this is a wave function for a free particle. But if this is a wave function for a free particle, then they say that this is a probability, that the probability should be, like the density multiplied by the volume, and then you take the integral. So for the whole space, when I take the probability, it should give me equal to 1. Now coming to this equation, when I say, आप लोग खुद इसको चेक करेंगे तो क्या आएगा? आप लोगों के ख्याल में, क्योंकि मेरा मैथमेटिक्स कमजोर है, कभी मैथमेटिक्स अच्छी होती थी, अब तो खैर बहरहाल वी लॉस्ट एवरीथिंग एज के साथ, प्रॉब्लम्स के साथ, तो So, what is the answer? Are we lost or no? Mathematically we are lost. Yes or no? इसको क्या कहते हैं, इस तरह के इंटीग्रल को क्या कहते हैं? Undefined, whatever the name may be. But if you look to the integral, we can't solve it. We can't solve it. Because whenever we go for, so now coming to the basic point, that maybe for understanding it might be okay and it helps a lot in many things. But when we go to the basic condition, Dr. Saab was talking about something that was square integrable. Square wave function be something that must be square integrable. Is it square integrable? No. This is not square integrable. So it means we are lost somewhere. We are lost somewhere. Basically what happens, the real wave function is a combination of plane waves like this. It is not a single plane wave. It is not a single. There are so many plane waves. All together they carry the particle. All together they carry the particle. And they basically make a form of a wave. And then, in that wave packet, somewhere the probability is maximum and somewhere the probability is 0 too. The probability is 0 too. And this is quite, for this I will recommend that you people should read quantum mechanics. किसी ने पढ़ा है आप लोगों में से? कोर्स पढ़ा है? बहरहाल everybody should read the first chapter of Kohantanuji. It's an amazing book. वो नहीं होता है वो बंदा जो है वो कभी कभी वो मेले आता है, वो चीजें दिखाता है, आखिर में वो भैया बेचता है. So now I'm here to sell my So मेरा जो है मेरा नुस्खा especially for quantum mechanics. बहरहाल देखिए कि the misconceptions, I just talked about couple things. You people can check and you people can see so many problems with our learning and the whole education system. Few examples here, but I'm sure that if you go you find so many of them. But at least like my main concern, it's the whole physics. But then within the physics, my favorite is quantum mechanics, because we have lots of problems in quantum mechanics. लेकिन ये भी बता दूं, I'm not a master of quantum mechanics because, as I told, my background is very weak. You need to be very strong. And for strong, it comes from where? From the books. But not from the notes. Not from the books written by people here, and not from the Indian books. Categorically, Indian books are no more different than our books we write. Hiring, being a vice chancellor, one of my question is, did you read any book in your subject? I was surprised to see that even in Qaid-e-Azam University, in some disciplines, the people even with Ph.D. degree, they told me that they never read any book, any course with a textbook. That was surprising for me. Ab to hamari university hai to. So then what happened? This girl, she came, and I think she heard that I like to know and talk about books. She came with books, 3-4 books, and all the books are written by people here, ये जो है जिस तरह ये क्वांटम मैकेनिक्स की कोई किताब हो गई और क्लासिकल मैकेनिक्स की, मेरे ख्याल में मिलती है इस तरह के कुछ लोगों ने कोई नोट्स को उठा के इधर उधर के जो है पलंदे शलंदे उन्होंने प्रिंट किए होते हैं टू मिसगाइड द पीपल. सो शी केम एंड शी प्लेस्ड द बुक्स ओवर देयर एट द टेबल, क्योंकि वो जानती थी कि इसको किताबें पसंद है और दिस इज हाउ ही विल हायर मी. Imagine what I would have done with her. मैंने कहा आप ये किताबें पढ़ती है? तो then she told me that someone said, this was her reply, that someone said that the vice chancellor, he likes books, he likes books. So when you go with some book with yourself. I said, I don't mean this. So anyway, like our whole system, as we discussed many things, and these things we don't know, it's not because we don't want to, but because we don't have that sort of desire. We are always looking for shortcuts. We are always looking for, our population is almost half of USA, but what is our contribution towards knowledge? आधे के मुताबिक उनके आधे के, no. 1/10 of them, no. 100 of them, no. We stand nowhere. And the main reason is, हर चीज में हम क्या तलाश कर रहे हैं? शॉर्टकट्स तलाश कर रहे हैं. कम से कम फिजिसिस्ट शॉर्टकट्स वाले नहीं होने चाहिए. और ये फिजिसिस्ट, they can fix things. They can fix not only physics, but they can fix everything once they decide. So these were kind of couple things I just wanted to share with you. I don't have, as I said earlier, I am myself a student and a weak student of physics. ये आपात साहब को पता है कि मैं कभी भी brilliant नहीं था ना. I have always been a weak student of physics, but I have a concern. I don't want other people to be weak like me. I want some people to be the stars of the sky of physics. That can only happen if I can share my concerns with you, and that can only happen when I encourage you that you people should follow the best way for knowledge, and the best way is understanding, problem solving, critical thinking. ये नहीं है कि बस ये तो हमने straight away MGH, क्योंकि मैं, so with these words, once again I'm thankful to the director Saab and the faculty members, especially Dr. Ayub Faridi, who invited me here to interact with you and discuss a couple interesting things about our misconceptions in physics. Thank you very much. अगर किसी का कोई